When programming, a lot of times we write functions, and the idea of a function is to take some form of data in, we call those the arguments, and then do something to that data, and then return the result. So when we have functions like this, one of the ways that we can think about our problems is through pipelining. So we take our data and we pipeline it through a series of steps that gives us a new output each step along the way, and then we pipe that into the next step. There are a lot of languages that are really excellent at showcasing this, and today I'm going to show you an example with F#. So if you've never written F#, that's okay. Don't worry about it, but they have a specific operator for pipelining. So does Elixir. So does Clojure. They call that threading in Clojure. But these languages, generally functional programming languages, have a way to work with pipelines. That being said, you can totally write pipelines in Java, in Go, in TypeScript. In fact, you probably do. You just don't have nice operators to help you like you do in F#. So let's take a look at a really straightforward Code Wars challenge. So here's the challenge. In a factory, a printer prints labels for boxes. The printer uses colors, which, for the sake of simplicity, are named with the letters A to Z, except for the letters U, W, X, and Z. Those are for errors. The colors used by the printer are recorded in a control string. So, for example, the control string would be AAA, BBB, HAI, JJJM, meaning that the printer used 3 times the color A, 4 times color B, 1 time color H, and then 1 time color A, and so on. Sometimes there are problems, such as a lack of colors, technical malfunction, and a control string is produced. Here's an example of one, where errors are reported with the U, W, X, or Z key. You have to write a function, hist, that's a histogram, which given a string will output the errors as a string representing a histogram of the encountered errors. So we here's the format of the output string. So for example, we have a letter, error letters are sorted in alphabetical order in a field of 2 characters, a white space, a number of errors for that letter in a field of 6, as many stars as the number of errors for that letter, and a carriage return, or a line feed depending on the language. So we can take a look at this, and sometimes looking at the examples on Code Wars is a little clearer than actually reading the description. So we have this string right here. So our histogram would be U2, some spaces, some stars, and then we have our carriage return, W5, some stars, carriage return, X2, and some stars. And this is the same example, but using dots to show the spaces that are used here. So you can see in between these, there's always 2 spaces. In between these, there's always 5 spaces. So this problem, I'm going to pull up my solution really quick. This problem is a really great example of pipelining. So again, if you don't know F#, that's A-okay. You don't need to know F# for this. This code should be pretty legible. We open our system package. We have some error letters that we define here. So we have a list of letters. These are the letters that were mentioned in our details. So U, W, X, and Z. I create a function called histFormat, and this essentially formats that string. So let's go back to the details really quick so you can kind of see what that looks like. So it's helping format this string. And then we have our hist function here. So in fact, I'm not sure how to pull this up. If we hit train again, it might show up. It does, yeah, right here. Okay, cool. So I'm just going to grab this and paste it in here, and then we can run the tests, and you can kind of see how this fits together. Okay, so our test passed, great. You can look at the tests here. Here's the actual, and then here's the expected output, so we're good to go. So how does this function actually work? What is this weird operator that, again, a lot of people probably haven't seen before? So this is the pipeline operator. Or pipe operator, or again in Clojure, threads. They call them the thread operator, or the threading operator, I should say, not threads. Those are very, very different. So the idea here is our function is called hist, and it takes in an S, which is a string, and it returns a string. The very first thing we do is we say S. So take S, our argument S, and then we're going to pipe that into this. So this is a count by function that's provided from the sequence namespace. And we provided a function, and we're simply just counting the letters. And then we take the output of that, and we pipe that into this function. So we filter, and what we're doing is we're filtering here the character and then the count. So this is transforming the type. So this is giving us a tuple where we have the character and then the count for that character. So then we pass that into the filter function here. This function just checks to see if the variable C is contained in our error letters. So if it's the letter U, W, X, or Z, we apply a filter so only those make it through. And then we take that result and we pipe that into our next function, which is sort by. So we're sorting by the value of the character. And thankfully, when we sort by value of character in F# in most languages, it's alphabetical, which is the requirement for us. Then we take the result of this, again, so we still have our tuples here at this point, and we map these into our hist format. So if we look at our hist format function here again, we have C, which is our character, and then we have our count, which is the number of occurrences that it pops up. We call sprintf, so this is a print function that allows you to pass in formatting identifiers like this. So the %C, %I, and then %S, and then we pass in C for C. So we get the character here, we get the count right here. Essentially, this last piece here is creating the star character count number of times. Great, so now that we have that, we know that the last thing we need to do is concatenate these with a carriage return as per the requirements. So we have to escape this backslash, but the rest of this is essentially taking the result of this hist function, which is going to be a list of these strings right here, and then it concats them with a carriage return. So that's how this works. The idea here is that when we're working with pipelines like this, it's very obvious what we're doing. We take S and then we pipe it into this, and the output of that gets piped into this, and the output of that gets piped into this, and the output of that gets piped into this. And you see the picture. It allows us to think about this from a step-by-step process and look at smaller chunks of code at a time. Additionally, if we want to modify the pipeline, we can come in here and add a new method, like maybe we want to map again here. And then we could define a function that does something. To keep this valid, we'd still need to do something like this. But the idea here is, if you want to add another step to the pipeline, you find where you need to add that step, and then you just go in and add that step right here. Again, a lot of languages don't have operators for pipelining like F#, Clojure, or Elixir does. And if you find yourself without those operators, you can still structure things in pipelines. A really good way to do that would be to create anonymous functions and put those in a list. And then you can apply the functions one at a time to a specific variable that you have or a specific object. And that kind of gives you the same idea. It allows you to think about things in sequences of transformations of your data, and then to apply those step by step. And if you need to adjust the pipeline, you can go into the place where it needs adjusting and add a new step, remove a step, or modify an existing step. Hopefully this has been helpful. It's a really different way to think about programming. If you have not done functional programming before, I highly recommend giving it a shot. If you know C#, F# is an excellent one to play around with. If you know Java, I would recommend looking at maybe Clojure, Clojure. It's a very fun language that won my heart many, many years ago. If you know Ruby, then I would maybe recommend looking at Elixir, which is essentially, it looks syntactically like Ruby, but it runs on the Erlang virtual machine. Hope this helps. Thanks, and have a great day.